Hi everybody, I'm back. We're going to go ahead and start with the next part of this lab experiment dealing with oatmeal. And so what I have in my hands are what they call the quick cooking oats. And I showed you on the video previously, I asked you to take a good look at the granules. And you'll notice these are a little bit broken compared to the oats, the rolled oats. And my thought is that they're broken because of the way they're processed and to classify them as quick cooking oats. So once again, I have a half cup of measured quick cooking oats along with a cup or 240 milliliters of water that I previously measured. Also note that I've cleaned all my utensils to conduct this lab experiment. Please take note of the cook time on the computer because that is part of the documentation for this lab experiment. So we're going to go ahead and bring this up to temp. And as soon as the water starts to boil, I will go ahead and place the quick cooking oats in the water. As I was saying earlier with the first lab part of this experiment, the granules have starches referred to as amylose and amylopectin. Well, when they're submerged in water, and particularly when heat is applied, the heat disrupts the hydrogen bonds between those starches. And the more heat you apply, of course, they begin to rupture or break, the bonds do, and water begins to penetrate into the granule. As water penetrates into the granule and more heat is applied, those molecules are disrupted, and the amylose inside the starch molecule actually leaves the granule and surrounds the granule on the outside. And that's what helps contribute to the actual thickening of the mixture. So that's the little bit of scientific chemistry part to this lab experiment. So once again, it shouldn't take long to bring this water up to boil. And as soon as it does, we'll go ahead and put these oats in there, and we'll really see if it's actually a little bit quicker cooking compared to those rolled oats. Okay, the water's boiling, so I'm going to pour my quick cooking oats in it, give it a little bit of a stir. Just a reminder, we never want to over stir any kind of hot cereal because we don't want to prematurely damage that granule. So it looks like it's boiling rather quickly. I'm going to turn the temperature down just a tad because this stove is easy to scorch things rather quickly. So there we go. I also kind of moved it off of the burner to help reduce the temperature a little bit quicker than just by turning it down. So you'll notice that the mixture is really starting to thicken pretty quickly compared to the rolled oats. And I should be able to take it off the heat in just a few seconds. So I'm going to be looking for you guys to comment on the quality of this video. I have my oldest son Caleb as my videographer, and he's actually using my tablet. Earlier I had my husband helping to work out the logistics, and so Caleb's taken over, and so it's really becoming, I guess, a family affair at this point in time. You know what they say it takes a village, and I really think it's taken the whole community of Ruston and Tech to help us switch gears and meet y'all's needs in a different capacity. So yeah, the oats are thickening pretty quickly. I'm going to remove it from the heat very shortly, and then once again we're going to go ahead and measure the cook weight, and I'll give you those numbers so you can document it for your calculations. Don't forget to document the time from start to finish so that we can compare the cook times between the 3 different variations that we're going to do. Alright everyone, I just pulled it off the fire and I'm going to go ahead and measure it. Remember, I had everything tared out to 0, so now I'm ready to gently pour the mixture into this glass container. See, always making a mess. That is me. Alright, it looks like the cooked weight is 199.7 grams. 199.7 grams. And I'm also going to document that for our records. Alright, we're going to take a quick break so I can get ready for the next part of the experiment. So we'll be right back.